No, I don't know where they are. They were supposed to be here by... Oh my gosh! Professor Zamila? How did you misfrizzle the entire class inside of my webcam? That's amazing. Well, now that you're here, let's get started. I'd like to begin with the words of Carl Sagan, as his are often better than mine. Astronomy is a humbling and character-building experience. Words I couldn't agree more with. The 13 years I've spent studying the subject have changed me as a person. And tonight I would like to share some of my knowledge with you, by the end of which I hope you'll have a better grasp of the scale of the universe that we find ourselves in. Now, to do this, we're first going to need to better familiarize ourselves with the large numbers that astronomers use when describing the universe. And once we have, we'll be able to talk about the size of planets and stars. And from there, we get to answer the question, how many of them are there? Let's begin, shall we? By getting a feel for the numbers. We're going to see some big ones today, but I have a technique that I like to use when I encounter large numbers. I like to consider them in seconds. Seconds are an excellent unit. We understand them from a young age, playing hide and seek, for example. So consider, if you will, the number 1 million. How long is 1,000,000 seconds? Well, turns out it's actually not that long. It's only about 11 and a half days. Entirely unreasonable for a game of hide and seek, but for our purposes, that's a length of time we can wrap our minds around and use as a jumping off point. Let me show you what I mean. If I were to then tell you that in the Omega Centauri cluster, there's 10 million stars, you can say, okay, well, 10 million seconds, 11 and a half seconds is a million. Multiply that by 10, you get 115 days. That's 10 million seconds. So we can see the growth between 1 million and 10 million. Let's take that further and talk about a billion. How long is 1 billion seconds? Well, the short answer is it's 1,000 times longer than a million and 1/1000th of a trillion. We can do some very easy multiplication to track this growth. Let's try that real fast. How long is 1 billion seconds? Well, it's 1,000 times longer than a million. 11 and a half times 1,000. That gives you 11,500 days. Or 31 and a half years. I have not lived to see 1 billion seconds yet, but I've seen 1 million many times. And that really hammers home for me just what a big difference there is between 1 million and 1 billion. And it gets even worse with a trillion. That's 31,500 years. So now that we have this technique under our belt, let's go ahead and put it into practice a little bit later on. I'd like to do so by talking about planets. I only have time to talk about the Earth. As seen here from Saturn, it is but a speck. And very often in talks like this, you'll hear it spoken about in like this. Oh, our planet. It is but a mote of dust in a vast and uncaring universe. Oh. And they're not wrong to talk about it like that, but doing so ignores just how gargantuan the rock is beneath our feet. And let me show you here. Thankfully, there is a team of Nagano et al. At Kawasaki University, and they found that your average human has a volume of about 65 liters. The Earth's volume is about a septillion liters. Have you ever seen a septillion used before? I've never seen a septillion used, but that's how many liters our planet takes up. And with a little bit of math, you'll find that you can fit about 16 hexillion humans in that space. So don't let anyone tell you that the Earth isn't large, because, boy, you can't even compare humans to the Earth. Our seconds analogy completely breaks down, because 16 hexillion seconds, that is 2.5 million times the current age of the universe. We haven't had enough seconds. So I'm about to tell you now that the Earth is small, at least compared to things like this. Our sun. Our own sun is actually quite large. It can fit about 1,300,000 Earths. But that is nothing compared to the star I'm about to show you. Allow me to introduce you to VY Canis Majoris, a red hypergiant. I know I made it yellow when I made the picture. I'm sorry, it's not important. What is important is that single pixel there. That's our sun. VY Canis Majoris. You could fit about 5 billion suns in VY Canis Majoris. And about 16 quadrillion Earths. It's just stupid big. And that's just one star. So how many stars are there then? Well, to answer that question, we need to first talk about galaxies. Galaxies are collections of ice, gas, dust, rocks, planets, stars. And Dr. Christopher Consolice, it's Italian, I don't have the flourish, I sincerely apologize, but he's at Nottingham University, and he estimates that the average galaxy has about 100 million stars in it. Our own galaxy, the Milky Way, is measured in the hundreds of billions, and larger galaxies number in the trillions of stars. And with that in mind, I would like to now show you my favorite picture that has ever been taken ever. No, it's not a selfie of me, though I am rather handsome. No, it is this. The Hubble Extreme Deep Field. What you are seeing on the screen is a collection of about 10,000 galaxies. Just takes my breath away. But the patch of sky pictured here would easily fit behind a grain of sand held out at arm's length. You are looking at a minuscule little patch of sky. But if you were to total all of the stars in all of the galaxies in our universe, you're going to get a very large number. And I've kind of had enough of large numbers, so instead I would like to paint a picture for you. Imagine you are standing on a beach. Look up the coastline. Miles and miles of sand before you. Turns out Dr. Jason Marshall has estimated about how many grains of sand there are on all the beaches on our planet. And it is nothing compared to the number of stars in our universe. And what's even more fun, the team of Kassan et al. At Cornell, they've been studying exoplanets. And we can now say with relative confidence that there are at least as many planets in our own galaxy as there are stars. And I'm going to leave you with that. Have fun. So here we are. We've reached the end of our journey, and by now you have a technique to help fathom these large numbers. And you've done so when considering the size of planets and stars, and you now have an answer for how many stars there are in our universe. Thank you so much for your time. It's been a pleasure sharing my passion with you.